So today I wanted to talk about my computer vision journey and the different projects that we've worked on over the years. So I've been in tech for 26 years, give or take. I was appointed to AWS Machine Learning Hero last year. I like to think of myself as a geek with social skills, and I'm known for the crazy ideas, and keep the crazy in mind with this presentation. Okay, I just want to lay out an agenda. We're going to go through our machine learning journey, showcase computer vision use cases, talk about research and development that we've done with AI, and working with interns, and having some fun. All right, so how did I catch the ML bug? I went to the 2019 Santa Clara Summit, and my sole purpose was to learn more about machine learning. I kind of knew abstractly what it was, but I wanted to know how it worked. And I went to various sessions, and there would be the CEO from some company, and he'd have an architecture diagram, and I kept hearing SageMaker, and they're like, but how does it work? So I ended up, at the end of the day, in a Deep Racer workshop. And if you haven't heard of AWS Deep Racer, it is a 1/18 scale self-driving toy car. And it's turned into a global phenomenon. And there are racing leagues, and AWS has done a great job of building this program. And it's kind of like a gateway drug for developers to get into AI. And that's exactly the effect that it had on me. I don't have the strong math background that a lot of data scientists do. And so I was intimidated by it. And by playing with Deep Racer, I found that, no, I really can do this. And what better way to get into it than gamifying it? So let's see here. All right, I already covered that slide. So I got into this workshop. It was a 2-hour deal where they did an hour of presentation, and then we had an hour to do some coding. And it's Python code, very abstracted system inside of the AWS console. And I formerly was a mechanic right out of high school. I started working on cars. And so I think some of that knowledge helped in terms of the settings that I chose to build my first model. And after about 15 minutes, the car started driving around the track. This is the picture of the virtual console. And so this is the car learning to drive in a virtual gamified world. And someone from AWS came up and said, wow, I'm surprised your model's performing really good. You should go drive it on the real track. And I'm like, wait, what real track? Down on the expo floor, they had a full-size track. It's like 26 by 17 feet. And it was the last hour of the day. I got a thumb drive, loaded my model on it. My car did the fastest lap of the day the first time and failed to complete any lap after that. And there was all this activity, and I saw people that were visibly upset because apparently I bumped them off the podium. And next thing I know, I've got this guy in a racing jacket standing on a milk crate with a camera so he could be as tall as me, with a video camera and a microphone asking me how I felt about this, and I had to just shift gears into television mode, which I don't know that I really have, but somehow I pulled it off, and nobody was able to beat my time, and next thing I know, I'm on a podium with 2 other guys. They gave us these awards. I had to help write a blog, and it was just a whirlwind. And the prize for winning this was that they sent me to reInvent, all expenses paid, in 2019, and that was my first reInvent. There were 64 people globally competing in this summit race and the virtual races. And we got to Las Vegas. We were in the MGM where they do all the boxing matches. They had like 6 racetracks out there. And I came in 63rd out of 64. And I was okay with that. I was definitely standing amongst giants. And the people who did this, who were doing well, these were data scientists. Like, they already knew this craft and were able to dig into it way deeper than I could at the time. But this is how I caught the ML bug, and it set off a series of fortunate events. So I started exploring computer vision, and AWS has another product called Deep Lens that came out before Deep Racer. And the city of San Jose had circulated an RFP that they wanted to deal with some of the traffic congestion problems in the city. And they wanted to work with a creative company in a startup capacity to try to build a system to address this problem. And about the same time, I was frustrated. You know, in Santa Cruz, we're a beach town. We have a lot of tourists, and sometimes you wonder why it takes 20 minutes to go 2 miles across town. So I thought, well, you know, I wonder if deep learning, like I learned it with Deep Racer, could be used to make decisions about how to control traffic lights. So I went down this path, and you know, this is in the middle of COVID, and we were already starting to feel the effects. Our company had lost about half of its business. We were getting PPP funds to keep our employees busy, and we took advantage of that and had them retrain to learn new skills while we were kind of sitting idle waiting to see what was going to happen with the pandemic. So I called up someone at AWS and said, hey, I understand you guys have these Deep Lens devices and we have this project we want to bid on, but you know, it's COVID, kind of hard times, like, would you guys just give us a couple of these cameras? And they said, you know, hey, if you write a blog article, we'll give you a camera, no problem. So they sent us this camera, and as we got through the RFP process, we actually declined that RFP. The city had wanted to take a different approach to controlling the traffic, namely using data sources like Waze, which I thought was okay. But I felt like we could get a lot more data using a camera, more data than we get today from the ground loop sensors and the radar and the stuff that has been used since the 1990s. So as we started to play with Deep Lens, one night I was walking out of the house and I stepped in poo. It was dark. I came back in the house. I'm typing on the keyboard, and I smell that familiar smell. And I thought, man, you know, this Deep Lens, I wonder if it could detect a dog, but only when it's pooping. Turns out it can. So I went to my engineer and I said, guess what you're going to do today? You're going to build a computer vision model that detects dogs pooping. And if you go out to your favorite search engine and you use their image search and type in pooping dogs, somewhat surprisingly, there are hundreds or thousands of images of pooping dogs out there. So what a great data set to build a model from. So we call this project the Pupinator. And at this time, AWS got wind of what I had done, and they called me up and they said, can we make a video about this project that you've done? And I'm like, wait a minute, I just used your machine learning technology to detect dogs when they're pooping and try to encourage them not to do that, and you want to make a video about it. Okay. This is an excerpt of kind of how this system works here, little loop. Yeah, and AWS promoted it, and it got like almost 600,000 hits on YouTube, so my mind was definitely blown. And that's a novel use case, right? You know, something frustrating, you know, okay, it's fun. But what that led to was the possibility of doing something more practical, like a PPE detector. At the time, you know, we were really enforcing masks. And obviously, some people didn't want to wear masks, and you know, businesses had to find ways to protect themselves. So we thought about building an edge device that would not unlock a door to a business unless the person at the front door was wearing their mask and wearing it properly. All right, so with the exposure of the Pupinator and some other stuff I was doing, I got recruited into the community builders beta group. So this is a group that anyone can apply to join. They take submissions twice a year, and I think the community is over 2,000 people now, and each person is assigned to a particular category. So if you're not in it, I definitely recommend it. It's a great place to get support and to meet people. And I mean, right here in this room, we have an example of community. And what I've found is, you know, the more you give, the more you get. So thank you for coming today and being part of this community. All right, so yeah, one other thing about the community builders is they tend to want to recruit people in that are writing about the technology. You know, they're really passionate about it. They're building things, writing about it, sharing knowledge with other people. That makes a good community participant. So my handler, as I call him, approached me and said, hey, you know, we're looking for some content. You got any ideas? And we threw around a couple of things, and he said, hey, you know, there's this guy in Greece named Costa, and he has this idea about using computer vision to see what's in your refrigerator. You know about deep lens, he knows about recognition. Maybe you guys could work together and collaborate and come up with a piece for it. So we did, and we got it published out there on dev.to, and you know, I went about my business. Moved back onto the traffic thing, but more on the what's in my fridge in a minute. So this is Matt. He was one of our interns, and we later hired him as a data scientist. And at the time, I was trying to figure out how to do this traffic camera technology. And so we got together and you know, got some sheetrock screws and some string, and we made this rig to hoist a deep lens 15 feet in the air and to take video of the traffic. And at the end of it, we figured, you know, this is a pretty heavy lift. There's a lot of complex stuff going on. Maybe we should focus on the decision-making part of the system, which is a cloud-hosted machine learning model based on deep learning that will actually make the decisions. And so that's the direction that we decided to go at that time. Oh, by the way, the police were actually right behind that tree interviewing somebody that perhaps was doing something they weren't supposed to do. And we walked by with all this computer equipment and stuff, and I think it's because Matt was wearing this vest that he just looks like a Caltrans worker. And you know, when they left, we kind of smiled and waved and just like, act like we're supposed to be here. And we got away with it. So in 2021, of course, COVID had not passed. But AWS wanted to do another video about that fridge thing. And so I thought, well, you know, what we did was kind of cool, but if you put a bunch of stuff in a fridge, it's really difficult for the camera to kind of identify all those different objects. So I wanted to raise the bar. And I said, you know, the unsweetened soda water, it's in every office, everybody's doing it, nobody's drinking soda pop anymore. And you know, I get to the office and it's like, oh, I forgot to pick up some soda down at the grocery store. Wouldn't it be cool if we could just have a real-time inventory of what the flavors of soda were and the quantity in the fridge? And if we were low on something, then it could send me a text message and let me know, hey, you got to go get some more of that grapefruit brand. So we decided to go ahead and do that. And of course, this kicked off some more collaboration. So this time was with Mike Chambers. He's AWS Hero out of Australia. He actually just recently joined AWS a couple of months ago. And my friend Spencer, formerly from Santa Cruz, he's with a company called eTribe, and he is a 3D artist, and he's into AR and VR, and I'm not. So I said, Spencer, I need to build a model of a can and to generate a bunch of images, because we tried taking pictures of images, and if you've ever tried to label an image data set, it's a lot of work. You know, you're taking hundreds or thousands of pictures, and you got to edit them and draw bounding boxes and all this stuff, and we don't have time for that. So Spencer built me this can. So that's not a real can, that's a 3D one. And I was able to get the label off of the cans by taking my iPhone in panorama mode and putting the can on a turntable and spinning the turntable, and it had the effect of unwrapping the label on the can, and I was able to crop out a rectangular image, and Spencer wrapped it. Mike contributed some code that does synthetic image generation using Blender, which is an open source 3D toolkit, and it has Python hooks. And so we were able to generate thousands of images of each flavor of soda pop with different angles, different camera angles, and different lighting angles. And so in order to build a good model, we had to consider, well, when you open the fridge, there's always some background lighting in the room, and it's always fixed. And the cans are always upright. So, you know, original attempt, we had cans upside down, there was light way over here, and I'm like, wait a minute, the cans are never gonna look like that in the fridge. So we're able to tighten up the code and limit where the camera could be placed and to limit the lighting. And that worked out and built us a pretty good model. And we use a recognition service for this. And that was another part of this piece was I hadn't used recognition Rekognition has this feature called custom labels that makes it easier for people to build computer vision models. And so this was kind of a, here's how to use Rekognition and do something kind of cool. So this is a picture from one of the models, and so as you can see, this one's identifying not 100%, not perfect, but it's picking up the lemon flavors in there. And so we kind of wrapped up this project, and AWS had a production company work with me. During COVID, I had to do all my own shots. It wasn't like they showed up with a camera crew. They'd send me a punch list of the different pictures that I need, or videos, scenes, whatever. I'm not a video guy. And we put it together, and so I got to be interviewed by the woman, Anushri, who founded the Rekognition project, and kind of walk through the use cases and how to use it. So that was pretty cool. So about this time, I was part of an internal AWS group on Deep Racer. So we were people participating in the community, and the AWS product team valued our opinion. And they got us in a room one day, and they said, you know, Deep Racer's great, the car is not inexpensive, and if you want to use it, you have to have a track. The track's really big, it's expensive, it's a huge barrier to entry for people to use this product, which is meant to make it easy for developers to learn computer vision and machine learning. So they said, we're going to open source this, and we've built a couple of projects, you know, that we think might be cool, but in order to make this public launch, we'd really like to have some projects from the community. So they went around the room and asked us what ideas we had. And so Wahim, he decided to do a miniature traffic light that the car could drive around a track. So it's not about racing, it's about obeying the rules of the road. And so he built this concept. And then Martin, he built a better mouse trap. He calls this RoboCat. And so it uses object detection to identify a mouse, and then it goes up and it makes a motion to kind of scare the mouse off. And they made a video about his project too. It's under AWS Innovators. He's one of the most recent episodes, and his whole family's interviewed, and this came from a mouse problem that he had in his house. They were getting into his closet, and so, you know, practical use cases of computer vision. Well, finally they got around to me. I was the last person to go, hey Chris, you got any ideas? Remember the crazy part, right? So about a week earlier, I read this article on The Verge about this guy, Luke Goodman. He used to live in San Jose, and he's part of this Nerf modding community that I didn't know anything about. But he's 3D printing parts to put into Nerf guns and to make them shoot farther, faster, stronger. And this took off as a business. And so he left San Jose. He's up in Seattle now. He has a massive warehouse that's full of 3D printers. I think he's got 20 staff members. And they literally cannot print these parts fast enough. They just keep flying off the shelves. And so I got a hold of, so this inspired me, right? So I said, well, hey, why don't we just put one of these Nerf blasters on a Deep Racer, and it can drive around a track and it can blast foam balls and inanimate objects. And the response was, can you do it in 3 weeks? And I'm like, what? You want me to put a blaster on one of your, okay, all right, yeah, I can probably do that in 3 weeks. It turned out that it took slightly longer than that, and they delayed the product launch just so that I could finish my project, because it was a little bit harder than the other ones. So what we did here is we got the 3D model for the LiDAR bracket for Deep Racer. That's the LiDAR and stereoscopic camera package for doing object avoidance and competitive racing. And so I work with Makerspace down the hall from our office, and they helped me out with designing a flat platform for this. And then the copper piece is a turret that's on a website called Thingiverse. You can just download free 3D models. And so we put the two together, and then that green blaster is a custom blaster that Luke, his company, made, and it's capable of shooting 15 rounds per second. It sounds like a machine gun going off. And which is why you don't want to fire one in a large conference room, especially these days. So I mounted this on here, and then what I found was there's a constraint with the Deep Racer platform is that they only gave you enough servo control ports for the throttle and the steering. So there was no way for me to control a turret if I wanted to. So I ended up extending the platform with a custom Arduino module and wrote a protocol and used some different open source libraries. And this is something that I'm really proud of because it's not just Deep Racer, this can be used for other things. And what it does is Arduino has multiple sensor pins that can be used for digital inputs and outputs and to control servos. So if you think about building a robot that goes into a nuclear reactor to detect the amount of radiation, or some other use case where you have sensors, this Arduino module and all of the code that I wrote is open source. If you look up Cloud Brigade on GitHub, you'll find it. So this allows you to extend the platform, and so I thought that was pretty cool. Anyway, because I keep doing crazy things, in 2021, they promoted me to AWS Hero, and I was able to speak at reInvent. And what I had pitched to them was this traffic project that we were working on. And although we had only worked on the cloud part of the project that does the decision making, we knew what we wanted to do with the camera vision to collect the data, and we knew that we're going to have to build an IoT controller to actually control the stoplights. So what we were able to do during that first phase of the project is there's an open source program called Sumo, and it allows you to simulate traffic. It's used in urban planning. And it also allows you to synthetically generate traffic. So we were able to generate the traffic, send it to SageMaker, to the model, get an inference back, and then visualize what the decisions were that the traffic lights are making. So this was a super cool tool to be able to do this. And just to give you an idea of what the system looks like, this is a slide from my reInvent presentation. So we use IoT both for the cameras and for the controller. MQTT is great for sending lightweight JSON payloads back and forth. And then we can collect data and use it to train new versions of the model to improve the traffic flow. So we got to 2022, we're still trying to figure out what the new normal is. And my data scientist that you saw on a previous slide, he said, hey, I got an idea. And I'm like, well, yeah, I'm usually the one who comes up with the crazy ideas, but go for it. He's like, well, it's Pi Day's coming up. And I'm like, so? That's a math thing. What's Pi Day about? Oh, well, people eat pie on Pi Day. Like, what if we built a model that could determine if something was a pie or not a pie? It's kind of like the hot dog, not a hot dog from Silicon Valley, right? So I'm like, okay, I'll buy it. Let's build something out. We had recently done a web application for a customer that was to collect image data and send it to an API. And so we decided to expand on that and make a system to allow people to take pictures of their pie on Pi Day, and then we would use a recognition model to tell them what kind of pie it was. So this is the Pi identifier in action. It's a fully serverless app. And now it's in action. So someone submits a picture of their pie. So this is actually apricot pie here, which the model doesn't know about apricot. And so I think it thought it was peach pie, which it wasn't. So we took this opportunity to use this as a crowdsourced data collector. And so we gave a list of plausible pies as well as the ability to type in one if it's not in the list. And then it would make an API call and collect that information, and it would allow us to take these images that they submitted, label them automatically with a little bit of human review, and then feed them back to the model and expand the number of types of pie and the accuracy of the model. And it's a novel idea. It was something fun. We had some downtime, and I got to speak about that at the San Francisco Summit last year. All right, so at this point we figured out nobody's coming back to the office. Accountant comes in once in a while, but we got this industrial space. Our office is in an old Wrigley chewing gum factory, And people I know that are old enough that grew up in Santa Cruz, they said when they were out riding their bicycles around town, what they smelled was the flavor of chewing gum that Wrigley was making that day. And they decided to close this factory in 1996, and a local commercial real estate guy, young up-and-coming guy, he had a vision for it. And so he was able to purchase this 400,000 square foot building, and that houses companies like Santa Cruz Bicycles, Blix, there's one other bicycle company, name's escaping me. There are artists in there, there are coders, there's just the makerspace. There's every manner of type of company there. So the space is relatively inexpensive. We know if we give it up, somebody else is going to take it. And what could we do with the space? So we reconfigured it, and we decided to turn it into a learning lab. So our company's done internships since 2010. We've run 60 internships as of this summer, and we've hired 18 of those interns as employees over the years. And it's really providing a valuable opportunity to engage with our community, to engage with the students, to help them to bridge the gap between where the college education leaves off and the job requirements start. And obviously it can serve as a partial pipeline for us as well. So I connected with Carissa, she's part of the AWS community, and for the user groups, and we did a Women in Tech event. And so that was, that put the deadline, like we had to clean the office and get it ready at this point. And the office is also big enough to house our Deep Racer track. I started a Deep Racer meetup in Santa Cruz right before COVID. So we have an opportunity to do that and host other meetups. And then we have several AI devices there. So we've talked to students at our local colleges about providing self-paced learning experiences. Like, you don't have to buy the hardware, we've got it, just come in the office. We'll do office hours, we'll help you along with it. And then this summer, we ran internships. 16 interns, that's more people than we have employees at our company. And we split it across 4 projects, and one of our interns who worked on our traffic project, he came in, he just finished his graduate studies, and he said, I'm not busy during the summer, I'd love to help project manage and mentor some students. So we took on the traffic cam part of this project, and a group of 5 students from UC Santa Cruz worked for 2 months and got a few lines of code away from having an almost completed product to be able to take video at an intersection and to inference the type of car or type of vehicle. Is it a car, a truck, a bus? The relative speed, what direction it's going, generating more data than our current machine learning algorithm needs to know to make traffic decisions. So it'll allow us to make a smarter machine learning model in the near future. We conceived of this art project called Close Encounters. It's based off of the Close Encounters of the Third Kind movie. So if some of you might remember from, I think it's 1977, the aliens landed on Earth in a spaceship, and we had to figure out how to talk to them using music and light. And so we had one intern who was from UC Santa Cruz. He lives in India. We managed him all remotely. Super bright kid, into music, and he was tasked with building a pipeline that can take a recorded sound sample that is not from a musical instrument to determine if it has a melody in it, to break down that melody into the constituent notes and tempo and beats, and then to produce a MIDI file as a result. And our original plan was to use AWS Deep Composer, which will take MIDI as an input, and it will return a 5-instrument composition that we can play back and assign our own MIDI instruments to. So this is really the rough proof of concept. We've submitted a proposal to the city of Santa Cruz to build out the entire art project, which would involve taking over the 2nd story of an office building and putting individually addressable LED lights in all of the windows, and a microphone and PA system at the top of the building where anybody who walks down the street can stop in one place and they can whistle, hum, yodel, make whatever kind of melody they can, however they can. We'll record that sample, we'll analyze it, we'll send it to a machine learning model, and then we'll return a composition with a nice light display. And we hope to run that around the holidays, so everybody cross your fingers for the city of Santa Cruz kicking us down some funds so that we can hire some interns at the school and build this thing the rest of the way out. Priorly is a productivity SaaS application that I conceived of several years ago. We did it, the original version was old school LAMP stack, and this is an opportunity for us to rebuild this in a cloud native serverless fashion. So we had a team of interns working this year to use AWS Amplify Studio and to rebuild our application and all of our data integrations, and we hope to have that in an MVP by the end of the year. And Space Lab, that was Matt's project. Matt, again, who was on a previous slide, he went to General Assembly, and his capstone project was using NASA data to locate exoplanets, which he was successful in. So he started a whole nonprofit called Space Lab, and they have people from around the world who are contributing their time to help make this system better and to sift through all this data that NASA has from the radio telescopes and to find more exoplanets. So this is the output of the camera project. So this is a YOLO V4 model with deep sort. And so this is able to identify the vehicle type and direction and to track each individual vehicle, not 100% perfect, but the idea is like in normal computer vision inferencing, you go, oh, okay, yeah, there's a car in that frame, but the act of tracking that specific car across multiple frames, that's a lot more complicated, and deep sort came to the rescue here. All right, how we doing on time? Do we have time for one more? Bueller? Okay, you guys like creepy stuff? Are there any ventriloquists in the room? So in 2019, I saw a kid selling a ventriloquism dummy on Facebook Marketplace. And it kept coming up in my feed, and I finally reached out to this kid, and he still had it, and I'm like, hey, you know, like, how attached are you to that thing? Because I want to take it apart and, you know, put servo motors in it. And he said, dude, that's sick. Can I help you? So I went down to the Santa Cruz Metro station, that's our big bus stop, and met this kid with about $180 in cash. Never met him before in person, and so we went to the middle of the bus stop. I handed him this big wad of cash. He handed me an aluminum briefcase, and I thought, some cop's gonna dive on us because it looks like we're doing a drug deal or something. So anyway, well, once you have a ventriloquism dummy, it is a license to freak your friends out, because I didn't realize how freaked out people get by ventriloquism dummies. So Danny Oday, that's his name, modeled after a ventriloquism dummy from about 1928. Yeah, he went with me everywhere. And then eventually I took him apart, and I glued some servos in there, and I got a motor controller, and so he has emotion. He can be good, or he can be evil. So here's another video. So, you know, I was like surprised at like, what does the inside of a ventriloquism dummy look like? How does it operate? So that's a little test program to do the servos, and then you can see back there, paper clips, turns out make really good linkage devices for servos. And so I conceived of this Alexa-powered ventriloquism dummy that uses computer vision to follow the person it's talking to and to make sure the eyes always follow that person. I thought I'd take it a step further and use recognition to store information about that person so that when the person came back the next time, Danny could say, hey, Bob, it's nice to see you. You know, how's that baseball thing we were talking about last week? I don't know if you can hear it. What time is it?
The time is 5:53 p.m.
Danny, what time is it?
The time is 5:53 p.m.
So what I was able to do there was to get the Alexa SDK loaded on a Raspberry Pi, and then with some third-party tools, I was able to change the wake word to Danny, because that's his name, and got pretty far along. In a bit of sad news, Danny's body burned up in the CZU fire. But I still have his head because all of my passion projects I kept in that office down in Santa Cruz. So Danny will live on, but I'm not sure what his body's going to look like. Maybe it'll be like that weird thing from Toy Story. All right. That's all I've got. Does anybody have any questions?
Thanks, Chris.
So if you want to look at Deep Blaster, it's over here. I've got some business cards. We have a small little boutique consulting company. We like to build cool and sometimes weird things. So the last revision they did was in 2019. I think it's due for some upgrades. I haven't seen anything recently about updates to it, so I think it's still running Ubuntu 16.04. So it would be nice to see it brought up to current, but it is a great toolkit that is already integrated with a lot of AWS services. So when we did the Pupinator, it was actually based off a blog post that an Amazon employee did. And his use case was he didn't want his dog on his couch when he was gone at the office every day. So he set up the deep lens to detect a dog, and then when the dog got up on the couch, it sent a SNS message to his phone, and it also streamed video to the Kinesis video stream service. And so that kind of gave us enough pointed in the right direction to then build our own custom model with the pooping dogs, and then we ended up hooking in MQTT, and then we just send a payload up to the cloud when the deep lens detects a pooping dog, and then we have an Arduino that we coded with MQTT with a relay on it, and then actually Doug Erickson, he runs Santa Cruz Works. It's a local business organization in Santa Cruz. When he came to our office and saw what we were working on, he got super animated because his neighbor, it doesn't clean up after his dog. So this dog runs 2 doors down, poops on Doug's lawn and leaves, and it's like a rivalry out of a movie or something, you know, comedy movie. So he said, I can totally use that. So Doug let us set this thing up at his house and wire into his sprinkler system, and then to turn on the sprinklers when the neighbor's dog comes over. So I had to laser cut a wooden housing and waterproof it, because the deep lens isn't meant to be used outdoors. And so we made this rig that was actually, you know, looked like it belonged in a garden. It had a nice wooden pole, and, you know, so that was kind of fun.
How about the upgrade for the Racer?
So Deep Racer went open source, and as I understand it, the platform they used previously is different than what they use now. They use the ROS 2 operating system. So when I went to work on this project, I had to learn that whole ecosystem. And essentially, it's a collection of software nodes that run at the same time. There's some quality of service that you can set because some things need to happen in a more real time than others. And then it uses a messaging system like MQTT to relay messages. And so, you know, in our Deep Blaster, we have an object detection model. It's set for a bottle. So if I put a soda bottle in front of the camera, it will identify it. And as I move the soda bottle to the left and to the right, we get an XY coordinate from the camera. And then we're able to send messages through their messaging system, the pub sub system, with the coordinates. And then we have static action space. So certain ranges of X and Y will cause the turret to rotate certain degrees left to right. Yeah, and actually, when I fired this up today, you know, I was kind of hoping to do a demo, but, you know, demos never work, right? You know, so I noticed there is an update for it. So, and poking around some of the open source files over at GitHub, I can see that AWS has done a fair amount of work since the last time I worked on it. So I'll have to get back on this. All right. Well, thank you so much for having me.
Thanks, Russ.